So when we add integers, there are some addition rules you can follow. If m is an integer, then 0 plus m is always m itself. And because of the commutative property, we also have m plus 0 being itself. If m and n are both positive numbers, then we just use the addition of whole numbers that we defined in the previous lesson. If m is positive and n is positive, then negative m plus negative n is negative m plus n. So remember, negative m is just m on the number line but going left from 0. N on the number line is n on the number line left from 0. So if we sum those two things together, if we combine those two lengths going left to 0, we will just be going left m plus n from 0 on the number line. If n is greater than 0 and m is bigger than n, then m plus negative n can use the commutative property to write negative n plus m, which is the same thing as m minus n. So if we add a negative, that's the same thing as subtraction. If n is greater than m and m is positive, then m plus negative n is the same thing as negative n plus m, which is the same thing as negative n minus m. So we talked about properties of integer addition with whole numbers, and integer additions inherit all of those same properties. So the closure property, for any a, b integers, a plus b is always a unique integer. The addition is commutative, a plus b is equal to b plus a, and addition is associative. A plus b plus c is equal to a plus b plus c. We still have that identity property. 0 is the unique integer such that for all integers, 0 plus a is equal to a, and a plus 0 is equal to a. We do get one more property with the integers instead of the whole numbers, and that's that an additive inverse property exists. So for every integer, there's a unique integer, its opposite, it's negative, or its additive inverse, such that when we add a and its inverse, we get 0. And due to the commutative property, we also have negative a equals a. So for example, 4 plus negative 4 is 0, negative 4 plus 4 is 0. Every integer has that additive inverse. So there's a theorem that we can talk about. So another thing that we know to be true about the integers. So if a, b, and c are integers, then the negative of negative a is just a itself. So we can think about the opposite of the opposite is the same thing. Addition property of equality for integers. So we can, if we have an equation or an equality, a equals b, then we can add the same integer to both sides of that equal sign and we maintain equality. And if we have negative a plus negative b, we can, in a way, factor out that negative from a and b, and we are left with negative a plus b. If we want to think about finding the additive inverse of each of these expressions, then we're looking for its opposite. It's thing that if we add to it, we will get 0. So the additive inverse of negative 3 plus x is just negative 3 plus x. Which is just 3 plus x. A plus negative 4 is negative a plus negative 4, which is just negative a plus negative 4 or 4. Negative 3 plus negative x is negative